Hi there, welcome to this video. This is MG5004 and DE5418 topic 3. This is class 1 and there are two parts to class 1, so this is class 1 part A. I'm sure you remember the basics of solving equations. Whatever you do to one side must be done to the other, and you can do all sorts of things, the normal sort of things: add and subtract, multiply and divide, take a power, take a root, invert, and so on. So let's have a look at these three here. I might not get them all on the same page, but let's have a go. So starting with the first one, so we have p plus 2 over 3 is equal to 14. Okay, let's start by multiplying both sides by 3, so we get p plus 2 equals 3 times 14, which is 42, and then subtracting 2 from each side gives us that p is equal to 40, and you should always check your answer. Second one, we have 3p equals p over 4 minus 11. Now once you start getting fractions, slightly more complicated fractions, you do have to be careful. Okay, to get rid of something over 4, we need to multiply everything, every term, by 4, so that we get 12p equals p minus 44. Subtracting p from each side gives us 11p. And then dividing each side by 11 gives us -4. And again, check your answer. So putting it back into the original, so negative 12 equals -4 over 4 minus 11. Yep, that works. So we've checked our answer and we're done. Looking at the third example, if we make the left-hand side find them a common denominator, the common denominator would be 6. So the first fraction we would need to multiply by 2. And then the second one we would need to multiply by 3. Top and bottom by 3. And the right-hand side we would also need to put over a common denominator of 6. So there it's over a common denominator of 1, if you like. So we need to make that equal to 6f minus 12 over 6. And at that stage we're ready to go. Just be careful of your signs. You've got a subtraction sign in the middle here, so just be careful of that. So expanding our brackets, we would get 4f minus 2 minus 3f. Now here's where the minus sign comes into play. Minus 3 times 3 would be minus 9 equals 6f minus 12. So from the left hand side, now I would like to line up my equal signs, but I can't really, I'm going to run out of space. So left hand side I would end up with 1f, and then I would have -11, and I could add 11 to the other side, so I'd get on the right hand side, I'd get 6f plus 1, and whoops, that should be -1 there. And then I could either transfer the 1 or I could transfer the f. Let's transfer the 1. So we have 1 equals 6f minus f, which would be 5f. And f, now dividing both sides by 5, and we have 1 over 5. And if you check that in your original, you find that you are correct, that each side is equal to -1.8. Here are the 5 rules, or roughly 5 rules, that you need to remember. But it's all about doing the same thing to each side. Basically, if you change sides, you change operations. So if you want to get rid of the times, you divide both sides. To find where this curve cuts the x-axis, we know there, where it cuts the x-axis, we know that y is equal to 0. So what we need to do is we need to solve where x squared minus 4x plus 1 is equal to 0. Now, we may or may not be able to factorize a quadratic. If you feel comfortable doing that, in this case it's not going to, so we need to use the quadratic formula. And if you remember, the quadratic formula says that x is equal to, now what we're comparing it with is ax squared plus bx plus c is equal to 0, and our rule tells us that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So comparing the general formula with our specific one that we want to work with here, then I always find it's a good idea to write out my a is equal to 1, b is equal to negative 4, and c is equal to 1. So now x is going to be equal to negative 4 plus or minus the square root of, now on your calculator make sure you do this, it's negative 4 squared minus 4 times 1 times 1, make that a bit bigger, all over 2 times 1. And if we put that through the calculator, we get that x is equal to approximately 0.27 or 3.73. So that looks about right. That point there would be the 3.73, and this point here would be the 0.27. And you should check that that's correct. It'll only give you the approximately. It'll only give you approximately 0, but that's because 0.27 is approximately the answer. Sometimes you're asked to find the equation of something that's a bit more complicated than a quadratic. In this case it's a cubic, but you're given the x-intercept, so you're given where y is equal to 0. So then in this case the cubic would be y is equal to x minus x1 times x minus x2 and x minus x3. Now just be careful about the signs. This is the big thing you need to watch out for, the signs of your x1, etc. Because when you put them in here, you just have to be careful. Another thing you need to check is your y-intercept. Does it work from what you've got in here? And sometimes it means that you need to put some number in here to adjust to make your y-intercept correct. And remember, the y-intercept is where x equals 0. Let's just pretend we don't know that for the moment. If we knew the intercepts, we could actually find the equation. So let's say that we know these intercepts, that x1 is equal to negative 2, x2 is equal to negative 0.5, x3 is equal to 1, and x4 is equal to 1.5. And suppose we know also that the y-intercept is 6. So then y is going to equal x minus 2 times x minus 0.5 times x minus 1 times x minus 1.5. Now, if we check by trying when x equals 0, that gives us a y-intercept of 1.5, and we're told that the y-intercept is 6. So what we need to do then is to multiply, or figure out what we need to multiply 1.5 by to get 6, and the answer is 4. So we need to multiply the whole thing by 4. And if we expand all our brackets and fiddle around, then we get what we had before I crossed it out. There are various ways of finding these x-intercepts. You can think of a number and divide by the bracket. So if you think maybe x equals 1, then you divide your expression by x plus 1, and that would then give you a cubic, and you could then factorize that if you needed to find the intercepts and you didn't know them. Otherwise, we can use Desmos, and hovering over the place where it crosses the x-axis would give the roots. Just a brief review of solving simultaneous equations. You've got two ways of doing it. You can either use substitution or you can use elimination. Let's look at substitution for our first example. So we've got two equations, x plus 2y equals -1, and I like to label everything. So let's make that minus. So 4x minus 3y equals 18. Now, because we're doing it by substitution, let's say that we get from equation 1, we get that x is equal to -1 minus 2y. We're going to put that into equation 2. So we get 4 times what we had for x. And get rid of the brackets. -4 minus 8y minus 3y equals 18. And from that we get, what do we get? -11y, that's an 18, equals 22. So y is equal to -2. And putting that back into one of them, x is equal to -1 minus 2 times -2, so we've put that back into here, and we've got that x is equal to 3. Now you should always check these, and we've used question or equation 1, so probably we should put it back into both of them just to give it a bit of a check. Okay, let's have a look at using elimination for the same equations. So we've got the same x plus 2y equals -1, and 4x minus 3y equals 18. Now if we multiply the first equation by 4, then we get 4x plus 8y equals -4. Give that a name, and then underneath it we're going to write equation 2. If we now subtract those two, so then we get 4x minus 4x is nothing. 8y minus -3y will give us 11y, and -4 minus 18 would give us -22. So y equals -2 as before. And putting that in the first one, will give us x equals 3 as before. Sometimes we'll get no solution, in which case then the lines are parallel, so they're not intersecting at all. And sometimes we get an infinite number of solutions, in which case the lines can be drawn like that. They're actually on top of each other. They are the same line. There are many applications of solving simultaneous equations. Kirchhoff's law is a common example, but in many cases an experiment or something will have been done, an equation needs to be formed to fit the data. So let's have a look at this one here. We've got 2 points of interest. We've got 5, 8, and we've got 6, 5. Now let's make the assumption that they are both fitting on a straight line. So the general form of the, oops, change my colour, of a straight line is y is equal to mx plus c. Now, what it means is that both of those points will fit y equals mx plus c. So we could put in there that 8 is equal to 5m plus c. And we could put in that 5 equals 6m plus c. This is a fairly straightforward one. If we take equation 2 and subtract from it equation 1, then we get that m equals -3. And then we can put that into 2 maybe. Maybe we can put it into 1, doesn't matter. So that 8 equals 5 times -3 plus c, and it will tell us that c is equal to 23. So now our equation is y equals -3x plus 23. And then we can use that equation, if we think it's linear relationship, we could use that to say, well, what happens when x equals, say, 4.1? So then we would just substitute into there and find that y was equal to 10.7. We could find the intersection graphically. Now, this only works if you've drawn your graph absolutely accurately, and you'd want to be very careful. You could use Desmos or something like that, and that would give you that point, but otherwise, now this is a very perfectly drawn graph because it was done on the computer, but if it wasn't and your pen was too thick, then you could see that the answer was approximately 2, 1, but not necessarily exactly. So what we would need to do, we would need to say, okay, we've got y equals x minus 1. That's named as equation 2. And we've got y is equal to 9 minus 4x. That's named as equation 1. So these would be equal to each other at the intersection. So we would just rewrite that as x minus 1 is equal to 9 minus 4x. And we'd then rearrange that. So we've got 5x equals 10. So that x equals 2, which is what it looks like on the graph. And then we could use that to find that y equals 1. And we'd want to check that both of those are true. This last graph is an illustration of what I said before. The two lines here are parallel. Now, they've been drawn not on top of each other. They're quite close because one's going through 1 here, and the other one's going through 1.5. They have the same slope. In each case, m is equal to 5. M is equal to 5. So the lines are parallel. They will never intersect. There's no way that you can find a solution. And as a useful exercise, you might try and find that, and you'll find some nonsensical statement. And when you get one of those, you'll find that there is no intersection because the lines are parallel.